So we've been looking at independent demand for our inventory management. Fixed order quantity was where we order the same quantity every time, and that quantity is typically the EOQ, or economic order quantity, that's minimizing our inventory costs. Fixed order interval was where we order at the same time, so every Monday or every third Wednesday of the month. So the time we order and the interval between when we place orders is the same. So we would change the amount we order, but we'd order at the same time. The third inventory management model we want to look at is the single period model. The single period model is used for ordering perishables or other items that have limited useful life. So we're talking about food, it goes bad. So there's a trade-off between having too much and too little that we have to consider, and we have to consider what we can do with the product after the day we try to sell it. Does it have any value? Can it be resold for something else? So we have to look at products that go bad or things that nobody wants old versions of. So for example, the newspaper. Nobody wants to pay for a 3-day-old newspaper. And so it would also fall under a single period model. Okay, so how do single period models work? Well, we need to calculate the service level. The service level is the percentage of time that we have enough on hand. So instead of with the fixed order interval, where you chose a service level of 90% or 95% or 99%, in this case, the service level is going to be based on the trade-off of having too much or too little. So we have a cost of a shortage. So what happens if a customer comes, let's say you're Tim Hortons, okay? You're Tim Hortons and customers come to buy donuts and muffins. If your customers come to buy your donuts and you don't have enough, you have a shortage, what is the cost to the business? Well, the cost to the business is the difference between what you could have sold that donut for, so the revenue per unit, and the cost to you to get that donut from your supplier. So essentially that's your profit margin, right? You gave up your profit by not having that donut when the customer came in. So revenue per unit minus cost per unit. Then we have to compare that to the cost of excess. What happens if you have too many donuts left over at the end of the day? Well, if you have donuts left over at the end of the day, you had to pay your supplier for those donuts. So there was a cost per unit. If the donuts have no salvage value, nobody wants a day-old donut, then the cost of excess is just the cost you paid to get the inventory. If having excess means you can sell it the next day, but it's no longer fresh, so it doesn't have the same price as before, then it has a salvage value. And so your cost of excess gets reduced by the amount you could sell the next day old donut for, the leftovers, okay? If it's going to cost you money to turn that into something else, then your cost of excess can be not only the cost that you paid for the product, but the additional cost to turn it into something else. So for example, let's say you're a grocery store and you have excess apples. The apples start to go bad. Well, you paid the apple farmer or the wholesaler for the apples, so you paid a cost per unit. Well, the old apples can be mushed up and turned into applesauce that's sold at the deli. In that case, the cost of excess is going to be the cost per unit, what you paid for the apples, plus the cost of labor to smush it up into applesauce, minus the price you can sell the applesauce for. Okay, so we have to consider what's the cost of having too much, what's the cost of having too little. And the service level takes the cost of shortage divided by the cost of shortage plus the cost of excess. So let's look at an example. All right, so let's suppose that muffins are delivered daily to a cafeteria. and demand varies between 30 and 50 muffins per day. The cafeteria pays 20 cents per muffin and charges 80 cents for it. Unsold muffins have no salvage value. Nobody wants a day-old muffin. So we need to figure out the cost of having too much and the cost of having too little. So the cost of a shortage is the revenue you would have made minus the cost to buy that inventory piece. So the cost of a shortage is we could have sold the muffin for 80 cents, but since we didn't have the muffin, we lost not 80 cents, but we lost that extra money we would have made off of that muffin, so we have to subtract the 20 cents it costs to get it from our supplier. So in this case, the cost of a shortage is 60 cents. Now, what's the cost of excess? Well, if we have leftover muffins, what's the cost to our business? Well, the cost of excess is the cost to buy the muffin from our supplier minus any salvage value. Well, if there's no salvage value, then the cost of excess is just the 20 cents we paid for that muffin. And since nobody bought it, we're out 20 cents. The service level, the percentage of time we have enough, is the cost of a shortage divided by the cost of a shortage plus the cost of excess. So in this example, that's 60 cents divided by 60 cents plus 20 cents. So our service level in this case is 75%. So we're going to have enough on hand 75% of the time. This takes into consideration that the cost of a shortage is much higher than the cost of excess. So the service level is going to be higher because it costs us more to not have enough. If the cost of excess was higher, then the service level would be lower because it would be more costly for the business to have too much left over. Now, when you have a service level of 75%, you can calculate what is called the stockout risk. This is the risk of running out of the inventory you need. Well, if the service level says that you have enough 75% of the time, then what percentage of the time do you run out? Well, the stockout risk is going to be 1 minus your service level. So if our service level is 75%, our stockout risk is 25%. Okay? Now, once we have the service level, we then need to figure out the optimal stocking level. So you want to have enough muffins 75% of the time. So then the question is, how many muffins do you order from your supplier to make sure you have enough 75% of the time? Well, that's really going to depend on whether your stocking levels have a uniform distribution, a continuous distribution, or a discrete distribution. So we're going to look at each one of these. Let's start with a uniform distribution. You have a uniform distribution if there is equal probability of you using up different amounts of inventory. So with a uniform distribution, you're essentially going to have some minimum level of inventory and some maximum amount of inventory that you use up. And if there's equal probability that you could use up the minimum amount or the maximum amount, then it's a uniform distribution. In this case, this example talks about how demand varies between 30 muffins a day and 50 muffins a day. Well, our optimal stocking level is how many muffins we're going to need to have on hand. Well, we want to have enough 75% of the time. So if this rectangle here represents our distribution, we want to find what is that number of muffins so that we have enough 75%. So we need a formula. The formula for a uniform distribution is your minimum plus your service level times the difference between the maximum and the minimum. So we know we need at least 30 muffins, but we want to have enough on hand 75% of the time. So the difference between 50 and 30 is 20 muffins. We need to make sure that we're somewhere between 30 and 50 muffins, but we need to have enough 75% of the time, so we need to add that 75% of a difference between the min and the max. So in this case, we have 0.75 times 20, and we have the 30 minimum, so our optimal stocking level is 45 muffins. Okay. Now, what if you don't have a uniform distribution? So let's take our same example, but instead of having it be a minimum inventory use and a maximum and some in equal probability in between, in this case, what we have is we have a central tendency. That is, we have an average. So there's a clumping. On average, we use a certain amount of inventory. Okay. When we look at continuous stocking levels, we also use continuous stocking levels when you can have partial units. In a second, we're going to look at the discrete distribution, which is what if I can't sell partial muffins? But let's assume for the moment that we can sell partial muffins, or that we're selling enough muffins that the discrete distribution starts to look normal. We'll talk about that more in just a moment. But we have a measure of central tendency, so we have an average amount that we're using up, and partial units. That puts us with this continuous distribution. So let's use the same cost of shortage and cost of excess as before, which means our service level is still the same at 75%. The difference here is that we need to calculate that optimal stocking level, and the formula now for finding the optimal stocking level when you have a continuous distribution is when you take the average and you add a z-score times the standard deviation. So we're going to need to know the z-score that goes with our service level of 0.75. Now in this example, demand averages 40 muffins a day, so our average, or mu, is 40. Our sigma, our standard deviation, is 5 muffins a day. And then our z-score is going to be based on that service level of 75%. So let's go to our standard normal table, and this time we're looking for the inside number to be 0.75. Okay, so we need 0.75 and the z-score that goes with it. So we look at 0.66, 0.67, 0.68. Okay, so closest we get to 0.75 is really about here. What's that, 0.67? Somewhere in between these two, 0.675. So we'll go here, let's use 0.67. Okay, so our z-score is 0.67. Standard deviation is 5, average is 14. Plug that into a calculator, so 0.67 times 5, 3.35, and we're going to add, of course, 14 to that. And we get 17.35. Okay. Oh, that can't be right. Let's try that again. How about the fact that our average is not 14? Our average is 40. Okay, so still 0.675, still a standard deviation of 5. We're just adding 40 to that 3.35, and that gives us 43.35. Okay, now we use this continuous distribution. If we can allow for partial units, then we're going to have an optimal stocking level of 43.35. We can get a fraction. If we're using the continuous distribution, because our average is a high number, we have a central tendency still, but it's just a higher number, so our discrete distribution doesn't work, then we would need to round up. So if you can't have partial units, we would need to round up and have 44 muffins. Now, if we're rounding up because we can't have partial units, then a better distribution to use is actually the discrete distribution. But when you get to high quantities, the discrete distribution just turns into a continuous distribution. So you can use the continuous to approximate it. But what if the amount that we need of inventory is a smaller number and we can't have partial units? Well, then we need to know how to use the discrete distribution. So same example as before. The difference here is that demand averages 8 muffins per day. Okay. Same cost of shortage, same cost of excess, same service level. Okay. But now, because we can't have partial units, we're going to use the Poisson distribution. And so the Poisson distribution uses an average, and they call that average lambda. Okay, so in our example, we had an average of 8 muffins a day. We need to figure out the optimal stocking level. Okay, so let's go to our Poisson distribution chart. So a Poisson distribution chart looks like this, and it really has 3 components to it. There's an x value along the left column here. There's lambdas across the top, and then we have our probabilities in the center. Okay, so in our example, lambda, the average demand was 8, and our service level was 0.75. And we want to know the optimal stocking level. So essentially what we're doing is we're trying to solve for x on this table. So we need to find a lambda of 8. So notice here the lambdas are in small numbers, and they can be in fractions of numbers. Because it's an average, let's say for example, one day your demand was 2, and the next day your demand for inventory was 3. Then your average would be 2.5. Even though you can't sell partial units, your average can be a fraction. And so that's why these lambdas here are not just whole numbers. But notice they're all very low numbers. Now we're looking for a lambda of 8, which we find here. And as we look for our service level, we're going through. Remember, our service level was 0.75. Now, if we stopped here at 0.7166, because these are discrete, whole number units, if we had a stocking level of 9, we would only have enough 71.66% of the time. Well, this is not 75%. So when it comes to the Poisson distribution, you always have to go with the number that's over the service level you're looking for. So we go down, lambda equals 8, and we would go and choose this one because it's more than 75%, which means the optimal stocking level would not be 9, it would be 10. Okay, so if lambda was 8 and our service level was 0.75, then the optimal stocking level would be, we would have 10 units on hand. So on average, we're going to need 8 units of inventory, but to make sure we have enough, we're going to have 10. Well, what if lambda was 10? So what if on average you used 10 units per day? Same service level. Okay, so in that case, we're going to go to our lambda of 10, and we're going to go down, and we're going to look for 75%. Notice there's no 75%. We're going to go with the next number above it. And so we're going to have an optimal stocking level now of 12. Well, what if we change that service level? What if the service level wasn't 75%? What if the service level was 90%? Well, if lambda is 10, so our average demand is 10, we would go down that same column and we would look for a number greater than 90%. So in that case, our optimal stocking level would be 14. So you see we're holding extra inventory because we want to have more of the time. Okay. If our average demand was 8 and the service level was 90%, then instead of holding 10 units, we'd hold 12. So you can see that we're holding extra units when the service level goes up. So let's go back here. So what happens to that service level when you start to change the cost of shortage or the cost of excess? So let's create a blank page here. And remember that our service level is the cost of shortage divided by the cost of shortage plus the cost of excess. Okay. So what happens if the cost of a shortage goes up? So it's more expensive now when your customer comes in and you don't have what they're looking for. So what impact does that have? Well, if we look at this formula, we've made the number on the top go up, and we have made the number on the bottom go up. Okay. So what does that do to your overall service level? Well, if the cost of a shortage has gone up, it's costing you more to not have enough. So what your response is going to be is your response is going to be to have more. So if the cost of having a shortage has increased and our service level before was 75%, we might up it to 80% because it's hurting us when we don't have the amount we need. If the cost of an excess goes up, so now it's more costly, let's say, to have stuff left over. Well, in the formula, cost of shortage divided by cost of shortage plus cost of excess, the number on the bottom of the formula has increased. When you increase the amount you divide by, so you're now dividing by a bigger number, then that's going to make your calculation go down. So if it's costing us a lot to have leftovers, then we're going to order less inventory. Okay, so our service level is going to be lower. Maybe instead of having enough 75% of the time, we're going to have enough 70% of the time. When the service level goes up, so service level increases, we want to have more amounts of time. That's going to make your optimal stocking level do what? It's going to make it go up. If your service level goes down, you don't have to have enough as much of the time. Your optimal stocking level, the amount of inventory that you're going to order, is going to be less.